This is section 4.7, graph linear functions. A linear function is written in function notation if it is of the form f of x equals mx plus b. And we read that as f of x, and what it means is the value of f at x. So don't let this confuse you, because f of x means the same thing as y. It's just notation. F and x are not different variables. It's just a way to use function notation and talk about f of x. So do not try to multiply f and x, because f of x is just the same thing as y. It's just a different way to look at it. Okay, so first example, what is the value of the function f of x equals 3x minus 15 when x is negative 3? So you might also see this question as, what is f of negative 3? Because it's asking, what is the value of the function when x is negative 3? So that's a different way to write the exact same question. So all we're going to do is plug in negative 3 where we see x. So 3 times negative 3 minus 15. So f of x equals 3 times negative 3 is negative 9 minus 15. So f of x equals negative 24. Or we could actually say f of negative 3 for this function is equal to negative 24. Again, that'd be the same thing as saying y equals negative 24. So the question might have said, what is the value of y equals 3x minus 15 when x is negative 3? And it means the same thing. We're just using function notation. Okay, and then we can also work backwards. So for the function f of x equals 2x minus 10, find the value of x so that f of x equals 6. So if it helps you, we can kind of think about this as if this said y equals 2x minus 10, and find x so that y equals 6. So same thing. All you're going to do is replace f of x, the notation, with 6. So 6 equals 2x minus 10, and it's way back to what we did before. Solve for x. So to get x by itself, add 10 to both sides. 6 plus 10 is 16 equals 2x. Divide by 2, and x equals 8. Okay, domain and range. We've talked about this a little bit before, but just to remind you, the domain of a function consists of the values of x for which the function is defined. And the range consists of the values of f of x, where x is in the domain of f. So again, don't let that confuse you. We talked about range being the y values, and y is the same thing as f of x. It's just notation. So then the graph of the function f is the set of all points x, comma f of x. So just like it's the set of all points x, comma y, f of x is the same thing as y. So this becomes important with real-world examples especially. So for one example, remember we talked about maybe we have a function that relates the height of a candle with the amount of time it's been burning. So we're not going to talk about the time it's not burning. We're only going to start with once we've lit the candle, right? So our domain, our x values, are always going to be greater than 0 or equal to 0. So greater than or equal to 0. And the range, well, that would depend on the final height of the candle, right? But it's never going to go below 0. You're not going to have a negative candle. So again, your f of x is always going to be greater than or equal to 0. Okay, so we can talk about function families when we talk about linear equations. You will see this again as we learn about different kinds of functions, but for now we're just talking about linear equations and linear functions. But what we want to do is compare them. So in our first example, we have lines that are all parallel because they have the same slope, and they all actually have a slope of 1, but they have different y-intercepts. So these are all function families that are just vertical translations of f of x equals x. Or you can think of that blue line up there, f of x equals x, it's the same thing as y equals x. So if that's our parent function, our function that hasn't been changed at all, the slope is 1 and the y-intercept is 0, the plus b, again, is just a vertical translation. So that top red line has a y-intercept of positive 2, so we could write that as g of x equals x plus 2, or f of x, h of x. Again, that letter doesn't matter, it just means a function of x. And then the bottom red line goes through the y-axis, or has a y-intercept of negative 3, so we could write h of x equals x minus 3. But these are all in the same function family. F of x equals x is what we call the parent function, where no translation has been done to it. And then these are just vertical translations of the parent function. Now again, we can look at our parent function, f of x equals x, but this time we want to look at how changing the slope affects the graph of the line. So in this case, they haven't changed y-intercepts. All of them have a b, or a y-intercept of 0, because they're all going through the origin, but they have different slopes. So let's look at this red line here first. Again, we can count between points. So notice it has a point right here at 1, positive 2. So to get to that, we can start at the origin. We go up 2, a rise of 2, over a run of positive 1. So this line right here has an equation, let's say f of x equals positive 2x. And again, no plus b or plus 0 because it's going through the origin, and that's implied. The plus 0 is implied. And then we can find the other one. So this one's going through the point 2, positive 1 right there. So again, count to find your slope. It has a rise of positive 1 and a run of positive 2, so 1 over 2. And maybe we call it h of x equals 1/2 x. So this time, our function family are all stretches or shrinks of the parent function f of x equals x. And that just depends on the slope or the coefficient of x. But notice they're both positive, so this is where m is greater than 0. And in our next example, again, still they're all in the function family of linear equations, but we're kind of grouping them. We're putting them in subgroups. So this time we have graphs where m, the slope, is less than 0. But notice they're all still going through the origin, so they do not have a y-intercept. But again, we can find the equation. So let's do this one first. Let's see, it goes through the point positive 2, negative 2 right there. So let's count from the origin. It has a rise of negative 2 over positive 2 to the right. So that's actually equal to negative 2 divided by 2 is negative 1. So if we were going to write that one, f of x equals, we could just write negative x. Remember, the 1 is implied. So then for the other one, this one right here, it goes through the point +1, -3 right here. So again, we'll count from the origin. -1, 2, 3 over +1, and -3 divided by 1 is -3. And we could write h of x equals -3x. So this time our function family are all functions that go through the origin, but we've changed the parent function by adding a negative coefficient. And that's it for this section.